Dear students, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am explaining some most important questions for coming NEET exam. The question is sugar X, it is found in honey. It is a keto sugar, exists in alpha and beta anomeric forms, and it is a levorotatory. Find out what is the X. We know very well glucose, D-glucose. Glucose is a dextrorotatory compound. Dextrorotatory compound. So this is not levorotatory compound. So this is wrong option. Then fructose. Fructose, it is found in honey, and fructose containing a keto group, keto sugar. It exists in alpha and beta anomeric forms, correct? Then it is a levorotatory compound. Fructose is a levorotatory compound. So the sugar X is fructose. Generally, natural honey containing equal amounts of D-glucose and D-fructose. D-glucose, D-fructose, both present in natural honey. But D-glucose is aldohexose, D-fructose is ketohexose. D-fructose is levorotatory compound, D-glucose is dextrorotatory compound. So that the above points are suitable for fructose. The next question is 5 moles of liquid X, 10 moles of liquid Y make a solution having a vapor pressure of 70 bar. The vapor pressure of pure X and Y are 63 bar and 78 bar respectively. Which of the following is true regarding the described solution? We know very well, according to Raoult's law, P total is equal to P1 naught X1 plus P2 naught X2. Here X1 is equal to N1 by N1 plus N2. X2 is equal to N2 by N1 plus N2. So what is the N1? First moles, 5 moles of X, 10 moles of Y. So that N1 value 5, total 5 plus 10, 15. So X1 value. Similarly, X2 is equal to 10 by 15. Then P ideal is equal to P1 naught value, that is 63 bar. Then N1 by N1 plus N2 value, X1 value, that is 5 by 15 into 63 plus 10 by 15 into 78. So this total value is equal to 73 bar. The measured pressure is 70 bar, which is lower than ideal pressure. It means XY interactions are stronger than XX and YY interactions. That means after mixing X and Y liquid, the new interactions are very stronger than individual interactions of that solutions XX and YY. So that the solution shows negative deviation. Option 2 is the correct representation. Next question is match list 1 and list 2. List 1 is some processes, list 2 is catalyst used in that processes. So in that first one is Haber's process. We know very well Haber's process is iron is used as catalyst. Iron is used as catalyst. So N2 plus 3H2 gives rise to ammonia preparation in presence of iron catalyst, molybdenum promoter. That is Haber's process. That's why Haber's process is iron catalyst. The next one is Waker's oxidation process. In Waker's oxidation process, it will be convert alkene to aldehyde. Alkene to aldehyde. Alkene to aldehyde. That is the Waker's process. In this we use either PdCl2 or CuCl2 catalyst. CuCl2 catalyst used in Baker's process. Next, Wilkinson catalyst. In that Wilkinson catalyst we use tris triphenyl phosphine rhodium chloride. This is homogeneous hydrogenation catalyst. Homogeneous hydrogenation. Homogeneous hydrogenation, that is Wilkinson catalyst. Tris triphenyl phosphine rhodium chloride. Then Ziegler-Natta catalyst. It is used for polymerization of alkene, polymerization of ethene, nothing but. So that is trimethyl aluminum titanium tetrachloride. This is Ziegler-Natta catalyst. So the correct option is A1, B2, C3, D4. Option 3 is the correct representation. The next question is the major product of the following reaction is. Question is the major product of the following reaction is. So next question is the major product of the following reaction is. They given an organic compound. It is related with methyl magnesium bromide, that is Grignard reagent XS, then followed by hydrolysis. In this molecule, this carbonyl group and nitrile group both can react with Grignard reagent. So if you observe that reaction, so benzene, that is C double bond O, CH2, CH2, C triple bond N. So both carbonyl group and nitrile group can react with Grignard reagent. In that Grignard reagent, methyl group acts as nucleophile, magnesium electrophile. So here in this carbonyl group, the pi bonding electrons will move towards oxygen atom, oxygen getting negative charge, carbon getting positive charge. So this methyl group will attack to this carbon, oxygen attack to magnesium. Same in this cyanide molecule also, this bonding electrons will move towards nitrogen, nitrogen getting negative charge, carbon getting positive charge. This methyl group will attack to carbon, and magnesium will attack to nitrogen. So finally we can get the product like this. Then it is further undergo hydrolysis, acidic hydrolysis. Due to hydrolysis, here bond break, H here and OH will attack to magnesium. Here also the bond break, H2 here and oxygen move towards carbon atom. So finally we can get that here OH is there, then CH3 is there, CH2, C double bond O, CH3. So this is the final product. So the correct representation is second option. The next question is, which one of the following compound does not decolorize bromine water? Actually, bromine water is decolorized by the compounds which have unsaturation. That means carbon-carbon double bond. So this bromine will undergo electrophilic addition reaction to carbon-carbon double bond. Otherwise, electrophilic substitution on an activated aromatic ring. Here, if you observe these examples, this is phenol, this is aniline. In these two cases, in phenol, the lone pair electrons and oxygen. In aniline, the lone pair electrons and the nitrogen will undergo resonance with benzene ring. So because of that, benzene ring will get more activated. So this activation of benzene ring will react with bromine water and bromine so that it will be decolorized. So phenol and aniline should be decolorized by bromine water. Then further, this is styrene molecule. In styrene molecule, carbon-carbon double bonds are available, so that in this carbon-carbon double bonds, bromine molecule will be attacked, so that decolorization takes place in styrene molecule also. But in cyclohexane, there is no unsaturation, and there is no activated aromatic compound. There is no activated aromatic ring in cyclohexane. That's why cyclohexane does not decolorize bromine water. So first option is the correct representation. The next question is, among the following compounds 1, 2, 3, the correct order of bond dissociation energy of CH bond marked with asterisk or star mark is. So here this is benzene ring CH bond, here benzene attached to alkyne group CH bond, here cyclopropene CH bond. If you observe that bonds with more S character, percentage of S character have higher bond dissociation energy. Bond dissociation energy. Higher bond dissociation energy. So if you observe that bond S characters, this is sp. The CH bond character is sp. So 50% S character is present. Then the CH bond is sp2. That is 33.3% S character is present. So this CH bond is sp3. So that is only 25% of S character is present in this. So that more percentage of S character, more strength the bond. Bond dissociation energy required more. So that sp CH bond dissociation energy is more than sp2 CH bond, then sp3 CH bond. So that more bond dissociation energy, that is strongest bond is sp CH bond. So that it required more bond dissociation energy. So the correct answer is second one is more than 1 then 3. So first option is the correct representation. The next question is match the list 1 and the list 2. List 1 is mixture, list 2 is methods of separation. In that first one is chloroform and aniline. Actually chloroform boiling point is 61 degrees centigrade and aniline also more boiling point. So that here the boiling point difference between chloroform and aniline is more. So that simple distillation is enough. Simple distillation is used to differentiate chloroform and aniline. Actually simple distillation is used to purification of the organic compound which have more difference in their boiling points. So that chloroform and aniline can be purified by simple distillation. Then crude oil in petroleum industry. We know very well this is we use fractional distillation. So fractional distillation is used for nearly very less boiling point difference containing organic compounds we can separate by using fractional distillation. So that crude oil can be purified by using fractional distillation. Then glycerol from spent lye method. Glycerol from spent lye method is soap used in soap industry. So this is used to purify by using distillation under reduced pressure method. So actually high boiling glycerol can be obtained from glycerol from spent lye method. So this distillation under reduced pressure is used in this method. That means high boiling point containing organic compounds can be purified by using distillation under reduced pressure method. Then remaining is aniline and water. Aniline and water can be purified and separated by using steam distillation. Steam distillation. So the correct representation is option 1.